Hello everybody, this is a quick video going over the exit slip questions for the cumulative review number 14. So let's get started. So the exit slip was multiple choice, but I'm just going to do free response here so you can check to see if your answer was right or wrong from here. Given that tangent of x is 3/4 and sine of y is negative 24/25, we would like to find cosine of x minus y. And this is an identity, and you will be given an identity sheet if this is on your test. This identity is the following: cosine of x, cosine of y, plus sine x, sine y. So in order to find what this is equal to, we need to figure out what sine is for both of them. So for both these situations, we need to draw some triangles in quadrant 3. So I'm going to draw this first one in red. I'm going to call this angle x because we have an x here. I'm going to draw the second one in green, draw also in the third quadrant, and call this angle y. So if I go back to the red graph, tangent is opposite over adjacent. So on this triangle, the 3 would go here, the 4 would go here, and this is a 3, 4, 5 triple. Now, what you need to remember though is that this is in the third quadrant, so the x and the y values are negative. The hypotenuse of 5 is never negative because you square both of these terms in the Pythagorean theorem. In the green graph, sine, which is opposite over hypotenuse, is in the third quadrant, so it would be opposite here, hypotenuse here, and you could use Pythagorean theorem, or you might know this is a 7, 24, 25 triple. Also, this is in the third quadrant, so the x and y values are negative again. Now that I have these values, I can plug in my ratios of what I know. So I'm going to leave blanks for all these different things. Remember, cosine and sine represents a ratio on a triangle. So cosine, again, is adjacent over hypotenuse. So cosine of x from the first triangle would be negative 4/5. Cosine of y from the second triangle would be negative 7/25. Sine of x from the first triangle is going to be negative 3/5. And then sine from the second triangle with y is negative 24/25 because sine is opposite over hypotenuse. Now that I have all my ratios for my triangles, I just need to multiply and combine. These first two fractions multiply to be positive 28 over 125. The second pairing multiplies to be 72 over 125. This would give me an answer of 100 over 125. But 100 over 125 can be reduced. They're both divisible by 5, but a larger number they're both divisible by is 25. Divide these both by 25, I get an answer of positive 4/5. Now, common mistakes on this question are the following. It's very easy to forget that the opposite and adjacent in the third quadrant are both negative. That can make a difference in your answer. Another common mistake is right here. A lot of students think that because this is a minus here that it goes automatically to a minus here. But please make sure you're using your identity sheet. And if you're doing cosine of x minus y, this becomes a plus. So please be aware of those things. The second problem, find all the zeros of the function. Please write your answers as coordinates. So this problem, we have 5 different terms. So the first thing I would do or consider to do is take out a GCF. There isn't a number that goes into everything, and I can't take an x out because this doesn't have one. So there's no GCF. And I can't factor this by grouping because there's 5 terms and not 4, which means that my best friend, my calculator, is going to be the best hope. And what we could do, again, is we could list plus or minus p over q, p being 90 and q being 4. We could list out every single possible zero, but I would suggest just using your calculator to start the process. It's going to be the calculator, and then you're going to be using synthetic division to help yourself the most. Again, sorry about my handwriting there. So if you grab your graphing calculator, and this time I'm not going to pull up Desmos, but if you grab your graphing calculator and graph it, this function, you should get a graph that is facing upwards, and you should get one that is crossing at -2, 0, and another 0 that's crossing somewhere between 1 and 2. So you should have a parabola that looks something like this, where it seems as though we have 2 possible zeros. Now, something to be aware of before we continue the problem. This original thing is 4x to the 4th, which means I have 4 zeros. So if the graph is only showing me 2, that means that 2 other ones have to be imaginary. So we have to find that algebraically. So here's what we would do. We would use synthetic division. We don't know what this root is, so I'm going to use -2 to start. We're going to put -2 in our box, write all the lead coefficients. We're going to reduce this polynomial down. Bring down the 4, multiply, combine, multiply, combine, multiply, combine, I believe. Multiply, I get a positive 90, which means I get a remainder of 0, which is great, which means that this is definitely a 0 or a root. So if I start my answers over here, -2, 0 is definitely one of my x-intercepts. I proved it algebraically. So what we would do from here is remember that these coefficients represent this function down a degree. So this is really 4x cubed minus 5x squared plus 36x minus 45 equals 0. This does not equal 0 because the remainder is 0. It equals 0 because we're still trying to find x-intercepts. So what I would do from here, because we do not know what this root is I would do factoring by grouping. Let's see if that works. My GCF here is x squared, and I'd be left with 4x minus 5. Here, my greatest number that goes into both is 9. If I divide these both by 9, I'm left with 4x minus 5 as well. So this factors to be 4x minus 5 and x squared plus 9 equals 0. If I set both of these pieces equal to 0, this one is going to get me a value of 5/4, which does make sense where it is on the graph, which means that I know that another 0 is 5/4, 0. And then this piece here, x squared minus 9, they're going to get me my imaginary answers. Because if I set this equal to 0 and subtract 9 over, and take the square root, we would get square root plus or minus. The square root of 9 is 3, so the square root of -9 is imaginary of 3i, which means that 3i, 0 and -3i, 0 are 2 more roots that are true. So the 4 answers are -2, 0. This is terribly written. That is 5/4, 0, 3i, 0, and -3i, 0. List the following about the given polynomial. This was number 3 on your exit slip. We want to know what the end behavior is. We want to know what the roots or x-intercepts are. We want to know what the multiplicity of each root is. So in order to answer end behavior, I would think about what this graph looks like as a sketch. If your highest degree is 4, this is more parabola-like. And not only is it more parabola-like, we have a lead coefficient that's positive. So we're going to have a parabola probably looking like that, facing upwards. So this represents your end behavior. As x is going to the right, as my graph is going to the right, what is the graph doing y values? It's going up. So y is going to infinity. As x is going to the left side, what is the graph doing? Well, the end behavior is also facing up, so this would also be to positive infinity. If this graph had a negative in front, both of these would be facing downwards instead, so both of these would be negative infinity. What are my roots? Well, the original equation is x⁴ minus 49x squared equals 0. The reason I set it equal to 0 is because I'm trying to find x-intercepts, and y is always 0 when I'm trying to find that. If I solve this in factor, I can take out a GCF of x squared, then I would be left with x squared minus 49 equals 0. I would continue factoring in here and get x plus 7, x minus 7. If I set all these parts equal to 0, x squared equals 0, x plus 7 equals 0, x minus 7 equals 0, I have 2 roots from here. I have -7, 0 as a root. I have +7, 0 as a root. And from this situation, if I take the square root of both sides, we will get x equals 0. So 0, 0 is also a root. Now, the reason that I put these 2 in red is because they differ in multiplicity than the green. Multiplicity means how many times does the root occur. This first situation here, because I took a square root of both sides, technically this is plus or minus 0. So even though it does not make sense to say positive and negative 0, technically this answer happens twice, so this has a multiplicity of 2. And a multiplicity of 2, if you were to graph it, means that the graph bounces. These two answers, however, only occur one time. Yes, it was originally squared, but when you factored it, there was only one -7 and one +7. So both of these have a multiplicity of 1. And what that means is that if you were to graph it, the graph would go through the x-axis. And this would bounce on the x-axis. So that's some good review from the beginning of Unit 8A. Last but not least, solve the equation using U-substitution. This was in Unit 8B. U-substitution is going to be handy for calculus, and this equation at first looks very confusing. Here's would be my suggestion. I noticed that x to the 1/5, if I take that and I square that term, that is the same as x to the 2/5 because I multiply these exponents. So that means if I call u x to the 1/5, that means that this is u squared. And so I could rewrite this equation as 12u squared plus 5u minus 2 equals 0. And we can factor this, factoring by grouping, split the middle term, and then we can come back and use this information soon. So that's what I'm going to do. Let's do this by split the middle term. To start that, you multiply a times c, and you get -24. You list all the pairs that multiply to be 24. Do any of these help me get my middle term? Yes, 3 and 8 do. 8 minus 3 specifically helps me get to be adding to be 5 and multiplying to be -24. So you'd split that middle term. I'm going to put the 8 by the 12 into 8u minus 3u. I'm going to bring down my 12u squared, and I'm going to bring down my 2, -2. I'm going to factor by grouping, take out 4u, and be left with 3u plus 2. Here, I'm going to divide out a -1 and also be left with 3u plus 2. So it factors to be 3u plus 2, 4u minus 1 equals 0. So my two answers for u are -2/3 and +1/4. Now, these are not the answers. Now, on the multiple choice, I made these answers because it's really tempting to say you're done here. However, the question originally was in terms of x. And remember we said at the beginning that u equals x to the 1/5. So that means that x to the 1/5 equals -2/3, and x to the 1/5 equals 1/4. So now if you solve these little equations, what you would do to get rid of a 1/5, the quickest way is to raise both sides to the 5th power. And if you leave and these cross out, if you leave your answers in terms of fractions, you would just raise both of these numbers separately to the 5th. So -2 to the 5th is -32. 3 to the 5th, 3 times itself 5 times, is 243. So one answer left exact is this fraction. And the second answer, 1 to the 5th is 1. 4 to the 5th is going to be 1024. So here are my two answers for x and not u. All right, guys, feel free to contact me if you have any more questions. I hope these extra practice were helpful for studying for your test. Thank you.